Hey everybody, welcome to the second semester here at Keystone Middle School. Excited, halfway through, we can do this thing. I know it's been probably the craziest year of school ever, but we're doing okay. So what I want to do today is I think I'm just going to spend the whole day going over this review that I gave you guys on Friday. Our test over this unit is going to be probably next Wednesday. We'll do some review. We'll finish up everything this week. We'll review. You guys have Monday off next week. I don't want to give you a test on Tuesday after you had a long weekend. We'll take a test Wednesday. So just making sure that we're kind of on the same page with all this stuff. I figured I'd just kind of go through it all, do it for you guys. And that way, if you guys have any questions, you can definitely ask me. So we started off with solving for x. So remember, our key here is that we want to get these bases to be the same number. In this case, they already are, which is really nice for us. As soon as we have those bases are the same, we know that those exponents also have to be the same. So we can set x minus 14 equal to 4x plus 2. And then I can just solve from there. So I minus x from both sides, 1x, right? That'll give me 3x plus 2. Then I subtract 2. I mean, negative 16 equals 3x, and then I divide by 3. So my answer for the first one there is negative 16/3 for x. Now in the second one, our bases were not the same. And so we're going to have to do a little bit of work there, right? So we have 2 to the 3x plus 2 equals 8 to the 5x plus 6. So you always take the bigger one, look to turn it into the smaller one, right? So can I turn 8 into 2? Well, in this case, yeah, I can't, because 2 to the third is 8. And then that would also be to the 5x plus 6. And this one would stay the same. And then remember, we got power to a power over here, right? We got to distribute. So that's going to be 2 to the 15x plus 18 equals 2 to the 3x plus 2. And now the bases are the same, we can set them equal to each other. And I'm going to subtract 3x from both sides. So 2 equals 12x plus 18. And this marker's dying. You guys can probably barely see that, huh? That one looks okay. We'll try this one. Hopefully this works out a little bit better. All right. And subtract 18. That'd be negative 16 equals 12x. And running out of space, divide by 12. And that's my answer. 4 goes into both of them though, so that'd be negative 4 over 3. Negative 4/3 looks like a good answer for number 2. All right, number 3. We got 9 to the x over 3, 27. Okay, so we want to change the bigger one to the smaller one. However, we can't make 27 into 9 to something. So in this case, we're going to have to change both of them. And 3's look like it would work really well, right? Because this is 3 squared. And 27 is 3 cubed. So distribute. I'll give us 3 to the 2x over 3. Over here, that's going to give us 3 to the 3x over 4 plus 3. And then we can drop the base because they're the same. So 2/3 x equals 3/4 x plus 3. Subtract 3/4 x. Let's see, 2/3 minus 3/4. Make them in the 12ths probably. That would be 8/12 minus 9/12. So that's going to be negative 1/12 x equals 3. And then multiply by negative 12. Or negative 12 over 1, right? That's the reciprocal. So negative 12, and x is going to be negative 36. Oh yeah, just at the bottom of the screen there. Nice. Okay, number 4. Luckily you only had 6 of these ones, right? They are tough. I totally agree with you if you are thinking that right now. So looks like we can change 25 to 5s. That's nice. 5 squared. Yeah, this is the same. So we go distribute. That'd be 12x plus 2. And then we can drop the base because they're both 5s. And it should be easy from here, right? Add 2x. 11 equals 14x plus 2. Minus 2 from both sides. Looks like 9 equals 14x. And then divide by 14. And nothing simplifies with 9/14, so we'll just leave it 9/14. All right. Number 5. All right, so it looks like here we have all different bases, which we definitely don't want that. But they all look like they could probably be 2s, right? So this one would be 2 to the 3rd. This one would be 2 squared. So let's do some distributing. 3 times 5x is 15x. 3 times 3 is 9. The bottom's going to stay the same. And then over here, 2 times 3 is 6x. 2 times negative 6, negative 12. And now we have all 2's, but over here we can use a different property, right? Because we're dividing. That means that we have the same base we're dividing, so we can subtract our exponents. So 15x plus 9 minus 3x. 15x minus 3x is just going to give us 12x, and then still plus 9. And then over here, we're just going to have 6x minus 12. So we subtracted these because they had the same base, and we're dividing. That's what the division rule says. And then from there, we can just finish it out with some solving, right? So 6x plus 9 equals negative 12, minus 9. 6x equals negative 21, and then divide by 6. That looks like it's simplified. 3 goes into both of those. Negative 7 over 2. All right, awesome. And then the last one of those, I think the rest of it was a lot easier than those first 6. Let's see. That one's pretty long too. All right. So again, we cannot change 125 to 25 because there's nothing with an exponent, right? So it looks like we need to change all these to 5s. So this would be 5 squared This would be 5 squared. And this would be 5 cubed. And then we can distribute our exponents, use power to a power here. So 2 times 1/2 x is just x. 2 times 3 is 6. 2 times 3/2 x is just going to be 3x. 2 times 7 is 14. And let's see, 3 times 7/2 x, that one unfortunately is not as nice as the other ones. That's going to be 21/2. And 3 times -3 is -9. And then again, we have all the same bases, but this time we have another rule over here, the multiplication rule, which says they have the same base, so we can add their exponents. So x plus 3x is 4x. 6 plus 14 is 20. And this stays the same. And now we can set them equal to each other. So 4x plus 20 equals 21x over 2 minus 9. And then we just got to do the hard stuff, right? So minus 4x from both sides. Remember, 4x would be 8/2. I'm just going to do that so that it's already common denominators. So 21/2 minus 8/2. 21 minus 8 is going to give me, what, 13? Add 9. That would be 29 equals 13/2 x. And then, did that get cut off? Are we good? Here, let me move it down a little bit. There we go. And then just multiply by the reciprocal. 2 over 13. And that's going to give me x equals 29 times 2 is 58 over 13. Yeah, that's it. 58 over 13. Nice. Cool. So, let's talk test-wise, right? Test-wise, you're going to have, 4 of those on your test, something like that, where you're going to get points for each step that you show me. Obviously, we'll do some on the review packet when you guys get that later this week, but definitely have some of those on there. Yeah, so got that going for us. All right, number 7 and 8, you just had the graph. So 7 was exponential growth, and we know that because the common ratio in the parentheses here is 3. It's bigger than 1, right? So we know that's going to be growth. So we have 2 times 3 to the x. So my initial value, we should do 1 negative, right? And then we'll go 0, 1, 2. Just make a little rough graph. We kind of know what it should look like, right? It should be going up from left to right in an exponential form. But let's just check out what we get here. So 3 to the negative first. 3 to the negative first is 1/3. 2 times 1/3 is 2/3. Plug in 0, 3 to the 0 is 1, 1 times 2 is 2. There's our y-intercept. Plug in 1, 3 to the first is 3, 3 times 2 is 6. And plug in 2, 3 squared is 9, 9 times 2 is 18. So we have exactly what we thought we were going to have. At -1, we have 2/3. So that makes a little bit of sense because our initial value, remember this number is always going to tell us our y-intercept, right? So there's our initial value. And then 1, 2, 3, 4, 5, 6. And then, your graph should just kind of look like this. We didn't have these questions, but the domain would be negative infinity to positive infinity, right? All real numbers is the domain. the range here would be where x is greater than 0. Or if you wrote it 0 to infinity with parentheses, right? It doesn't include 0. Very cool. So there's our exponential growth one. And then for our exponential decay, we know this one is exponential decay in number 8 because our common ratio is a fraction, less than 1. Cool. So if we plug in -1, x to the negative first, that's going to flip this. So 1/2 to the negative first is going to be 2. 2 times 5 is 10. And remember, you can use your calculator when you plug that in, right? I'm just doing it in my head. Hopefully that doesn't confuse you. And I don't think I went up high enough because that's definitely not 10. That's only 8. We got 2 more. There we go. When I plug in 0, we get our initial value. 1/2 to the 0 is 1. 1 times 5 is 5. We expected that. When I plug in 1, 1/2 to the first is just 1/2. 1/2 of 5 is 5/2. And when I plug in 2, that would give me 1/2 times 1/2 is 1/4. 1/4 times 5 would be 5/4. So at -1, we're all the way up here at 10. Our y-intercept is here at 5. 2, that's like 2.5. So a little bit between 2 and 3. And it's a little bit more than 1. Like there. So kind of follow the curve, right? There we know it's going to do this. And there we go. So there's our exponential decay function. Cool. All right, the 4 on the back are all story problems where you had to use your models for exponential decay or exponential growth, or maybe compound interest, right? So I'll kind of set those up for you. So the first one here, a bond was purchased for $500. That's our initial value. It goes here. They offer an interest rate of 4%. We know that rate, we got to change it to a decimal. Compounded yearly, so only once a year. How much would it be worth in 20 years? So that t goes up here, and it's times 1 because it's only yearly. So there's what your formula should look like when you set it up. And then when you solved it, I'm not going to go through every step with you, because hopefully you just use your calculator. I got $1,095.56. So here's what I got when I set the first one up. Number 10. It says Mark won $20,000 on a scratch-off lottery ticket his grandma bought him for Christmas. Oh, that was so sweet of her. Thank you, Grammy. He decides to put it in a savings account, so his initial value is 20 grand. Savings account is offering him 3.2%, which would be 0.032. Compounded quarterly, that'd be 4. How much is it worth in 5 years? So that's 5 for the T, and we still need a 4 out there because of, because it's compounded quarterly. So that's what it should look like when you set it up. And then when I solved it, I got $23,455.28. Don't forget that 28 cents. It's important, right? Okay, so there's the compound interest ones. And then, let's see what else we got. Population of tigers is decreasing. So there's our keyword. We know this is exponential decay because it's decreasing. Okay, cool. I'm glad I know that. At a rate of 9.6% yearly. So how many do we start with? 3,890. It's going to be 1 minus our rate, which was 0.096. And that's to the x. And they want to know how many years it would take until there was only 2,000 tigers left. Or I guess it should say less than 2,000 tigers left. Right? Because that would be weird if it was exactly 2,000 tigers. Anyway, so here's what it should look like when you set it up. Or if you subtract it in here, that would be 0.904 to the x. And if you just kept plugging in numbers and trying it, that would work. Or if you use the table in your graphing calculator, that's an excellent feature that you could definitely use. You could even graph it on Desmos or something and see when it's less than 2,000. But it's going to take at least 7 years before the year starts and there's less than 2,000. There's 2,000 or less tigers. All right, and then the very last one here is another population one, the Bahamas. In the year 1990, there was 16,470 people. 16,470. It's growing at a rate of 4% each year. How many people live in the Bahamas in 2021? So the rate, it's growing, so we know that's growth. So we're going to put a plus sign in there. At 4%. So there's our function. Or if you add it in here, it would just be 1.04, right? And then again, this time we can actually figure out what year they want. From 1990 to 2021. Oh, I did that wrong. I need my calculator real quick. It's 31 years since 1990. I was trying to pretend like I was still younger than I should be. Do all this hard math and then you count wrong. I put 21 years. So let's see what happens when you actually put the right number there. So that'd be 31 years. So 1.04 to the 31st times that by 16,470. And you're going to get a lot of fives. 55,555 people. Or I guess 56 if you rounded it up, because it was 0.5 at the end. But it looks cooler with all the fives, so it almost looks like I planned on that, which I did not. All right, so that's kind of all I got for you today. Just going over that review, kind of getting our minds out of a funk that you've had a whole week off of school. Tomorrow we'll do geometric sequences, which are a little bit like arithmetic sequences, but they have to do with exponential functions. And then we'll talk about shifts on Wednesday, and then we'll start reviewing for your test next week. Cool, I'm out of here. Glad to see you again. Second semester, woo!